Good morning to all of you. Today we are going to discuss about the Lami's theorem, law of polygon of forces, resolution of forces. In earlier session, we learned about the law of parallelogram of forces, triangular law of forces. A light revision of the same thing will be done for our good memory. Law of parallelogram of forces, we have to take the resultant as the diagonal of the parallelogram, and accordingly its mathematical approach formula r is equal to square root of p square plus q square plus 2pq cos theta. In order to find the direction of the resultant, that is alpha, tan inverse of sigma f of y by sigma f of x, that is nothing but tan inverse q sin theta, that is sigma f of y divided by p plus q cos theta, nothing but sigma f of x. To the next one, triangle law of forces. In that example, we are already seen the triangle law. We make the forces as the sides of the triangle. We should arrange like that. There should be a continuity in the direction, like in clockwise or anti-clockwise direction, so that the third side of the triangle will give us resultant or equilibrant. To get the resultant, the arrangement of the third side in the direction should be opposite to the continuity direction of the other two sides. If the other two sides are in clockwise direction, then the resultant should be in anti-clockwise direction. If the other sides are in clockwise direction, anti-clockwise direction, then resultant should be clockwise direction. For the equilibrant, E should obtain opposite to the resultant. That means in the same side of the other two forces, same direction of the other two forces. That means if the two forces are making an anti-clockwise direction, then equilibrant is also in the clockwise direction. If other two sides are making a clockwise direction, then the equilibrant also makes clockwise direction. That is the major difference between the resultant and equilibrant. The mathematical approach of the triangle law is same as of the parallelogram law. Just we arrangement of the sides should be formation of a triangle shape. Here also the resultant will be r is equal to square root of p square plus q square plus 2pq cos theta. Remember, the arrangement of theta should be keep in mind as per the diagram shown above. And alpha is equal tan inverse q sin theta by p plus q cos theta. For today's session, we are emphasizing on the following learning outcomes. First one, Lami's theorem and its computations using this theorem. Some problems we will do, and resultant of a system of coplanar concurrent forces by law of polygon of forces and resolution of forces or analytical method. The law of polygon of forces is similar to the triangular law of forces that we will elaborately discuss in the upcoming session, upcoming slides. Lami's theorem is intended for the three forces among which If one or two are unknowns, you can find out that one using the Lami's theorem. Earlier in the triangular law and parallelogram law of forces, we deal only two forces, whereas in the Lami's theorem, we will deal with the three forces. In the polygon of for law of polygon of forces, we deal n number of forces. Before starting to the Lami's theorem, it is also follows the Co-planar concurrent force system. What is the Co-planar concurrent force system? If the line of action of all the forces meets at a point, irrespective of its their direction in one plane, is called concurrent force system. Here you see there are three forces F1, F2, F3 are in a plane, that means they are coplanar, and they are meeting at a point, that is concurrent point. Therefore, the similar arrangement we will be seen in the Lami's theorem also. The cases of coplanar concurrent force system, when only two forces are non-collinear concurrent point, we are already seen in the parallelogram of forces and two line forces. Now we are seeing the three forces. Now we are seeing the three forces in Lami's theorem. So that you should mind of it. So here we are not seeing the two forces, we are seeing three forces. You please mind it. We are seeing the three forces. Those forces are like this. Those forces are like this. That is the arrangement of the forces in the Lami's theorem. So there are four numbers like forces are F1, F2, F3. Like this, three forces are acting at some angle. You can see here there is some angle in between the forces, and here is some angle in between the forces, and here also some of the angle in between the forces. So this Lami's theorem basically describes about the three forces which are concurrent at a point O. They are concurrent at point O. So and at a plane. Hence, it is a coplanar concurrent force system when three forces, when three forces when we are dealing about the three forces. And similarly, Polygon law of forces is also resultant can be obtained by using the practical concurrent force system. Now we are going to deal with the Lami's theorem. As earlier I explained about the system, how it looks like. The Lami's theorem applied in static analysis of mechanical and structural systems. The theorem is named after Bernard Bernard Lamy. So he is the person who has stated about the Lami's theorem. So in this system, this theorem is applicable when only only static equilibrium is applicable. When static equilibrium is applicable, then only this Lami's theorem is useful. According to this theorem, when the three forces acting at a point are in equilibrium, then each force is proportional to the sine of the angle. He emphasizes on the sine of the angle between the other two forces. This is it should be noted that this between the other two forces, that sine of the angle should be taken the opponent of the other two forces. We will see in the next slide. That should be like this. See the figure which is having the three forces Fa, Fb and Fc are the three forces. Fa, Fb, Fc are the three forces, and alpha, beta, gamma are the three angles. There are alpha and beta and gamma are the three angles. Subtended, the arrangement will be look like this. This is the arrangement. So there are three forces Fa, Fb, Fc, Fa, Fb, Fc are the three forces. Here it is Fa and Fb, Fc are the three forces are subtended with an angles of alpha, beta, gamma. When I am talking about the Fa, I should take the angle between the other two forces. What are the other two forces? If I am talking about the Fa, the other remaining forces are Fa and Fb. Hence, I should take the sine of angle between the other two forces, that is Fa and Fb. Hence, I should take the sine alpha. For the Fa, I should take the sine alpha. I should take the F sine alpha. And if I am talking about the Fb, then what are the other two forces? Then Fa and Fc are the other two forces. Then I should take the angle between the Fa and Fc. Hence for the Fb, what is the angle? Beta. That is the sine beta. If I am talking about the force Fc, then the other two forces are Fa and Fb. Then what is the angle between the both Fa and Fb is? It should be the gamma. So I am taking the gamma. So remember this type of opposite angle should be taken, which is subtended between the other two forces. We should take the in the Lami's theorem of the sine angles. You see the in the next figure. So this is the mathematical formation of a forces. In the earlier, you can see I had given some graph here because while drawing it can be expressed in terms of the geometrical. Also you can get these values by drawing this one. Fa, Fb, Fc are graphically can be drawn with taking some scale. 100 Newton is equal to 1 mm, like that. According to the intensity given as per your convenient scale, you can draw this one. But after drawing this one, you can apply this equation, which is obtained from the coplanar systems. Fa by sine alpha is equal to Fb by sine beta is equal to Fc by sine gamma. Thus derivation will be looking like this by adopting the resident equilibrium conditions. What are the resident equilibrium conditions? Fa plus Fb plus Fc should be equal to 0 in terms of the vector. It is not like that a simply addition. It is in terms of the vector addition. It is in terms of the vector addition. It should be vector addition. So that you should take in this one. Then only it will be a resultant equilibrium condition you will establish. Now this is the solution. By getting the complementary angles and triangle law of vector, you can get that solution. So you have to take the complementary angles and triangle law of vector addition. You get the derivation of this one. So just we are rearranged this diagram into the triangular form, as we say in law of triangle of forces. The similar way of concept also we have to employ it. Then you get this diagram. So by as per the sign vector notations, this can be resolved as force Fa divided by sine 180 minus alpha. This is an opposite side. You can see that opposite angle 180 minus alpha. So sine 180 will gives the 180, hence sine alpha. Sine 180 minus alpha is nothing but sine alpha. Similarly, you will get this equation into like this. So I am making Fa is equal to F1, Fb is equal to F2, Fc is equal to F3 for our notation. Hence this will comes into the, as engineering mechanics, we deal like this: force 1, force 2, force 3, or force at A, force at B, force at C, like that. But vector, it is not acting at a single point, it is a line of action is there. Hence we are terming it as a F1, F2, F3, like that. So F1, F2, F3. So in the Lami's theorem, we understood that the opposite signs, opposite angle between the opposite forces taken as the sine theta, that has to be as under the denominator of the selected force, that is the third force. Therefore F1 by sine alpha is equal, F2 by sine beta is equal, F3 by sine gamma. Now using the Lami's theorem, just we are interested to find out the forces F1 and F2 as shown in the figure. Here in this figure, you observe that there are three forces are concurring at a point O, and F1 is a purely negative y-axis. F1 is negative y-axis. Y-axis. Hence, you can easily calculate the angles by referring from the F1. And F2 is making an angle of 40° with the positive x-axis. Is making an angle of 40° positive y-axis. So this type of uh, arrangement is given for easily calculations. And from this scenario, you can get it the angles between the F1 and F2, F1 and F3, and F2 and F3. By seeing the figure, you can identify the angle between the F2 and F3 is 30 plus 40, that is 70 degree. So similarly, we have to identify the angles between the vectors, force vectors. Now I am using the equation of the Lami theorem because there are three forces and conditions are like this. Three forces should be acted and they all are should concurrent at one point, and they have not a linear forces, they are separated. Hence I had taken this F1 by sine alpha is equal to F2 by sine beta, it's equal to F3 by sine gamma. From the figure, the opposite angles for F1 is equal to 30 plus 40 as from the figure, 70 degree as alpha. The opposite angles for F2. F2 from the figure you can see this for the sine beta. I am calculation I am making calculations for the F2. So I need to obtain the angles. Now this is the angle. What is the angle here? It is 60. This one is 60. And what is the angle here? This is 90. What is the total angle here? That is 90 plus 90 plus 60. You get it 150. So this is the angle I had represented there. You see here, this is the angle what I had given as 150 degrees. So I got like this. Right? In the similar manner, F3, what is the opposite side? This is the opposite side. So where here you can get the 90 plus 90 plus 50, you got the 140 degrees. So where the 50 is came? Here 50 because of this one. This is the 50. The 50. So I got the total force as a 140. Therefore total angle, sorry, for the F3 force is 140. So I used the same thing in the calculation. So this one is 140 gamma, right? So I had given this clear picture in the solution. So I calculated the alpha, beta and gamma for the opposite forces. Now this is the total picture of the calculated values. F2, F3 is subtended by an angle of 70 degree. F2 and F1 is subtended by an angle of 140 degree, whereas F3 and F1 by 150 degrees. So applying the sine rule at a time for the, because here two forces are unknown and there is equality sign between the two forces. So total there is a equality. You should understood that there is a equality symbol is here. Here it is a equal, here it is a equal. Hence I wish to take these two terms at a time, right? After that, f1 by sine alpha is equal to f2 by sine beta. But in the diagram, you see that we know only F3, not the F1 and F2. Hence, I am not going to take the F1 and F2 at a time because these two are unknowns. Hence, I am taking these two for at a time. I know F3, hence I use only F1. Therefore, F1 by sin alpha is equal to F3 by sin gamma. See in the example solution. You see, this is what I had used. F1 by sin 70 is equal to 300 by sin 140. So I used the F1 and F3 at one time and F2 and F3 in the second time so that I can solve the F1 from this equation, F1 from this equation, F2 from this equation. So I got F1 from this equation and F2 from this equation. So I got like this. Right? Similarly, you can also substitute these values and you get the answers. You can manipulate these F1 and F2, F3 accordingly given condition of the diagram. This is my final answers after solving the F1 and F2, and this is the representation. F1 is came as 438.57 Newton, F2 is 233.36 Newton. After understanding of the Lami's theorem, we are traveling towards the Polygon Law of forces. To understand better, just recall the triangle of forces where we make the forces as sides of a triangle. In similar manner, in the Polygon Law of forces also, we are making it as a sides of the polygons. What is a polygon? It is formed by more than two sides of straight lines of any number of sides. So it means polygon has number of sides. Minimum it has more than two sides. We termed it as a polygon. The basic polygon is triangle. So polygon law is an extension of triangle law of forces. Hence we can say it as the polygon law is an is a extension of triangle law of forces. It is an extension. It is an extension to the triangle law of forces. So for the similar procedure what we adopted in the triangle law of forces, the same we should continue for the polygon law of forces too. It says that the number of forces acting on an object can be makes as a sides of a polygon, then the closing side will be your resultant gives in opposite direction. This the forces should be acting simultaneously and the magnitude of the resultant can be the closing side in the opposite order. You see, this is the system. If this system is there where an object in a plane at a concurrent point there are four forces are acting, this can be replaced by the Polygon law of forces to get the resultant. In earlier three losses, that is parallelogram law of force and triangle law of forces, we are dealing with the only two forces. In the Lami's theorem, we dealt with three forces. Now in the Polygon law, we are n number of forces can be dealt by the Polygon law of forces. Just we are assured that these should be makes a sides of the polygon as we did in the triangle law of forces. So for these four forces, system can be replaced by the sides of the polygon in the one direction to form continuity so that the resultant will form as a closing side of the polygon. మనం ఏమి చేయక్కర్లేదండి. పాలిగన్ షేప్లోకి ఫోర్సెస్ని మొత్తాన్ని మనం తీసుకున్నటువంటి స్కేల్ అంటే నువ్వు ఎజ్యూమ్ చేసుకున్నటువంటి స్కేల్ దాని పరంగా డయాగ్రమాటిక్గా రిప్రజెంటేషన్ గీసుకుంటా పోతే ఎన్ని సైడ్లు వచ్చినా పర్వాలేదు. అన్ని ఫోర్సెస్ని రిప్రజెంటేషన్ చేసుకుంటూ పోయిన తర్వాత ఫస్ట్ ఎక్కడైతే మీరు మొదలుపెట్టారో ఫోర్సెస్ అన్ని డ్రా చేసిన తర్వాత ఎక్కడైతే ఆగిపోయారో ఆ రెండు పాయింట్లకు కనుక మనం కలిపితే వచ్చేది రిజల్టెంట్. ఆ సైడే మనకి రిజల్టెంట్. ఆ రిజల్టెంట్ని మనం ఈ ఏవైతే అరేంజ్మెంట్ మనం ఫోర్సెస్ని చేస్తున్నామో ఆ క్రమానికి ఆ యారోస్కి ఆపోజిట్లో ఉండి తీరాలి అంతే. దట్ ఈస్ యాజ్ సింపుల్ ఇట్ ఈస్. చూడండి ఈ ఫోర్స్ సిస్టమ్ మొత్తం ఫోర్ ఫోర్సెస్ని మనం ఎలా చేసాం చూడండి. యూ జస్ట్ సీ ద యారోస్ హియర్ హౌ ఇట్ విల్ బి లుక్స్ లైక్ దిస్ హియర్. యూ ప్లీజ్ కాన్సన్ట్రేట్ హియర్. హియర్ ద యారోస్ ఆర్ యారోస్ ఎట్లా ఉన్నాయండి ఇవి టువర్డ్స్ ది ఈ డైరెక్షన్లో, అలాగే ఈ డైరెక్షన్లో ఉంది, ఇది కూడా ఈ డైరెక్షన్లో ఉంది, ఇది ఈ డైరెక్షన్లో ఉంది. కానీ రిజల్టెంట్ ఎట్లా ఉందండి? రిజల్టెంట్ కంప్లీట్గా ఆపోజిట్లో ఉంది. చూడండి వీటి యొక్క పాత్కి ఈ యొక్క పాత్ ఇట్లా ఉంది. యాంటీ క్లాక్ వైజ్ డైరెక్షన్లో మనకి పాత్ నడుస్తుంది. అన్ని ఫోర్సెస్ ఎట్లా ఉన్నాయండి? యాంటీ క్లాక్ వైజ్ డైరెక్షన్లో నడుస్తూ ఉంది. కానీ మనకి రిజల్టెంట్ ఏ డైరెక్షన్లో వస్తుందండి? రిజల్టెంట్ డైరెక్షన్ చూడండి ఎట్లా ఉంది. రిజల్టెంట్ ఇట్లా ఉంది, ఈ డైరెక్షన్లో ముందుకు వెళ్తుంది రిజల్టెంట్. అంటే ఇది ఏ డైరెక్షన్ అండి? ఇది రిజల్టెంట్ వరకు మనకి క్లాక్ వైజ్ డైరెక్షన్లో నడుస్తుంది అనమాట. సో దట్ ఈస్ ద డైరెక్షన్ వీ షుడ్ టేక్, రైట్. సో ఈ అరేంజ్మెంట్ ఏదైతే ఉందో ఇదే మనకి పాలిగన్ అరేంజ్మెంట్ అంటాం. సో ద మ్యాగ్నిట్యూడ్ ఆఫ్ ది రిజల్టెంట్ విల్ బి ది క్లోజింగ్ సైడ్ లెంత్. ఈ లెంత్ మనకి ఏమిస్తుందండి? మనకి ఇట్ ఈస్ ద మ్యాగ్నిట్యూడ్ ఆఫ్ ది రిజల్టెంట్. దిస్ ఈస్ ద రిజల్టెంట్. సో ఈ ఏదైతే ఇప్పుడు మీరు పాలిగన్ లా ఆఫ్ ఫోర్సెస్ గురించి తెలుసుకున్నారో, ఈ ఏదైతే ఈ ఎదురుగా మీకు ఒక ఫిగర్ ఆబ్జెక్ట్ కనబడుతుందో, దిస్ ఫిగర్ ఈజ్ అరేంజ్డ్ బై ది four forces. From this there is also a closure size is there which is represents the resultant. Can you identify the resultant here? In order to identify the resultant, a shortcut is at a point two arrows are meeting. Generally what happens, arrow and tail అనేది నడుస్తూ ఉంటుంది. To identify the resultant you should look for the where the two arrows are meets. See here, ఇక్కడ టూ యారోస్ ఉన్నాయండి. ఇక్కడ ఒక యారో టైల్ ఉంది, ఇక్కడ ఒక యారో టైల్ ఉంది, ఇక్కడ ఒక యారో టైల్ ఉంది, ఇక్కడ అసలు యారోసే లేవు. కానీ ఎక్కడున్నాయి టూ యారోస్? ఇక్కడ ఉన్నాయి టూ యారోస్. హెన్స్ దిస్ ఈజ్ ద జంక్షన్. నో వాట్ ఈస్ ద రిజల్టెంట్? మరి నెంబర్ 2నా నెంబర్ 3నా రిజల్టెంట్? అంటే మనం ఏం చేయాలి? ఈ పాత్ని అర్థం చేసుకోవాలి. ఇప్పుడు 5వ నెంబరు, 4 నెంబరు, 1 నెంబర్ చూడండి ఎట్లా వెళ్తున్నాయి. ఇవన్నీ కూడా యాంటీ క్లాక్ వైజ్లో వెళ్తున్నాయి. మరి 2వ నెంబర్ కూడా ఎలా ఉంది? యాంటీ క్లాక్ వైజ్లోనే ఉంది, ఇదే డైరెక్షన్ ఫాలో అవుతుంది. మరి 3వదో ఫాలో కావట్లేదు. హెన్స్ దిస్ ఈజ్ ద రిజల్టెంట్. వాట్ ఎక్కడుందంటే రిజల్టెంట్ ఇప్పుడు మనకి దిస్ ఈజ్ ద రిజల్టెంట్. దిస్ ఈజ్ ద రిజల్టెంట్. సో ఆన్సర్ ఏంటండి? రిజల్టెంట్ ఈజ్ 3. రైట్. సో That is the understanding of the Polygon force. Okay. Next, moving to the another topic, that is resolution of forces. Any vector, that is say force, that is directed at an angle to the known coordinate axis can be considered have two parts. అంటే ఎన్ని పార్ట్స్ ఉన్నాయని చెప్తున్నాం మన resolution of forces ని two parts ఉన్నాయని చెప్తున్నాం. ఒకటి, each part is being directed along one of the coordinate axis. ఇందాక మనం ఏదైతే ఫోర్స్ సిస్టమ్ గురించి మనం మాట్లాడుతున్నామో ఈ ఫోర్స్ చూడండి, ఇక్కడ F2 ఎట్లా ఉందండి? F2 స్ట్రైట్గా ఉందా? ఇట్లా స్ట్రైట్ ఉందా? స్ట్రైట్ లేదు కదండి. ఇట్ ఈస్ నాట్ ఇన్ ద స్ట్రైట్ లైన్. ఎలా ఉంది మరి ఇది? ఇట్ ఈస్ అన్ ఇంక్లైన్డ్ పోర్షన్. ఇట్ ఈస్ లైక్ దిస్ ఇంక్లైన్డ్ పోర్షన్స్. సో ఫోర్సెస్ అనేవి ఎప్పుడు స్ట్రైటే ఉండవు కదండి. జనరల్గా ఎలా ఉండొచ్చు, మనకి ఇంక్లైన్డ్గా ఉండే అవకాశాలు ఉన్నాయి. సో ఇంక్లైన్డ్ ఉన్నటువంటి ఫోర్సెస్ని మనం మ్యాథమెటికల్ ఫామ్లోకి ఎలా కన్వర్షన్ చేసుకోవాలి? దట్ ఈస్ నోన్ యాజ్ రెజల్యూషన్ ఆఫ్ ఫోర్స్. సో రిజల్యూషన్ చేసుకోవడానికి మనకు కావాల్సినటువంటి టూల్స్ ఏమున్నాయి మన దగ్గర అంటే, దేర్ ఆర్ నథింగ్ బట్ అవర్ కోఆర్డినేట్ యాక్సిస్. మనకి ఏం తెలియాలి? కోఆర్డినేట్ యాక్సిస్. కోఆర్డినేట్ యాక్సిస్లో ఏమిటి మనకి? ఎక్స్ డైరెక్షన్ అండ్ వై డైరెక్షన్. సో మనకి ఇచ్చినటువంటి ఇంక్లైన్డ్ ఫోర్స్ని మనం దేనిలోకి మార్చుకోవాలి? జస్ట్ ఇది ఇంక్లైన్డ్ ఫోర్స్ అయినప్పుడు దాన్ని ఎలా కన్వర్షన్ చేసుకుంటున్నాం మనం? ఒకటి వర్టికల్గా, ఒకటి హారిజాంటల్గా కన్వర్షన్ చేసుకోవాలి. సో దీనికోసం మనం మ్యాథమెటికల్ ట్రిగ్నామెట్రీని యూజ్ చేసుకుంటాం. మీకు తెలుసు కదండి, ఇఫ్ దీస్ త్రీ ఆర్ ఇఫ్ ఐ కంబైన్డ్, వాట్ విల్ యూ గెట్ ఇట్? I just want to combine these three. So these three forces I am just combining. This is the horizontal force and vertical force. This is the vertical force, right? So I got these two. Now the inclined force will be forms the closing side, that we know that, right? So in the same way we are going to do as a resultant to be this one of the one inclined force has been converted into the horizontal and vertical. So we are now using the sin theta and cos theta. What is sin theta? Sin theta is equal, if you know the diagonal, then opposite side by the diagonal. Cos theta is what? Adjacent side by the diagonal. So cos theta gives the horizontal force, cos theta gives the horizontal force, and sin theta gives the vertical force. According when, if the inclined force has been shown theta with respect to the horizontal. If the theta is not like this, if theta is some with respect to, if theta they are given with respect to vertical, then scenario will changes. How it will changes? This will gives the f sin theta, f sin theta, and this gives the f cos. So that is the difference. Here you see, for this figure, you see how it will come. This one is f cos, f cos, and this one is f sin. So we please understood this difference. Theta ఏ యాక్సిస్కి అయితే ఉంటుందో ఆ యాక్సిస్ కాస్ అవుతుంది, ఎఫ్ కాస్ టీటా అవుతుంది. ఆ ఫోర్స్ ఏమవుతుంది, ఎఫ్ కాస్ టీటా అవుతుంది. ఏ యాక్సిస్కి అయితే లేదో అది ఏమవుతుంది, ఎఫ్ సైన్ టీటా అవుతుంది. సో ఆ డిఫరెన్స్ అనేది మీరు కంప్లీట్గా గుర్తుంచుకోవాలి. యూ సీ దిస్, హియర్ ఐ హ్యాడ్ గివెన్ ఎఫ్ సైన్ టీటా, ఇక్కడ ఎఫ్ సైన్, ఎఫ్ కాస్ టీటా, ఇక్కడ ఎఫ్ సైన్ టీటా. ఇక్కడ సో ఆ డిఫరెన్సెస్ మీరు అర్థం చేసుకోవాలి. ఎందుకని టీటా పొజిషన్ చేంజ్ అవుతుంది కాబట్టి చేంజ్ అయిన టీటా పొజిషన్ని బట్టి వర్టికల్ కూడా ఎఫ్ కాస్ టీటా అయ్యే అవకాశం ఉంది, ఎఫ్ సైన్ టీటా కూడా అయ్యే అవకాశం ఉంది. అలాగే హారిజాంటల్స్ కూడా ఎఫ్ సైన్ టీటా, ఎఫ్ కాస్ టీటా కదా ఇంటర్చేంజెస్ అయ్యే అవకాశం ఉంది. సో వైల్ సాల్వింగ్ ద resolution of forces system, you should notice the where is the theta, where they are given the theta. సో ఇది ఈ ఎఫ్ కాస్ థీటా, ఎఫ్ సైన్ థీటా రెండు వేరు వేరు. ఈ థీటా అనేది పొజిషన్ గనక మనకి హారిజాంటల్ యాక్సిస్తో థీటా ఉంటే వర్టికల్ కాంపోనెంట్ ఎఫ్ సైన్ థీటా అవుతుంది, అలాగే హారిజాంటల్ కాంపోనెంట్ ఎఫ్ కాస్ థీటా అవుతుంది. అలా కాకుండా థీటా కనుక మనకి వర్టికల్తో కనుక ఇస్తే అప్పుడు వర్టికల్ యాక్సిస్ ఉన్నటువంటి ఫోర్సు ఎఫ్ కాస్ థీటా అవుతుంది. అలాగే హారిజాంటల్ ఫోర్స్ అప్పుడు ఏమవ్వాలి, ఎఫ్ సైన్ థీటా అవ్వాలి. సో ఈ డిఫరెన్స్ రెండు ఇంటర్పోలేషన్ అవుతాయి, అది బాగా గుర్తుంచుకోవాలి మీరు. అదే అరేంజ్మెంట్ ఇక్కడ మనం చెప్పడం జరిగింది. సో ఎఫ్ హారిజాంటల్, ఎఫ్ వర్టికల్, I taken a theta as 70 degree, then sin theta is equal to fy by f, because opposite side by diagonal. Therefore, what is the opposite side of the 70 degree? Which is vertical. Vertical axis is we are terming as fy, hence fy by f. Cos theta is equal to adjacent side by diagonal. What is the adjacent side? Is f horizontal, that is fx, right, by f. సో హారిజాంటల్ని హెచ్ అనొచ్చు, వర్టికల్ని వి అనొచ్చు, అలాగే హారిజాంటల్ని ఎక్స్ యాక్సిస్ అనొచ్చు, వర్టికల్ని వై యాక్సిస్ అనొచ్చు. సో ఎఫ్హెచ్ ఈజ్ ఈక్వల్ టు వాట్ ఈస్ ద ఫోర్స్ బై ఈక్వేటింగ్ దిస్ వన్, యూ విల్ గెట్ ది, హియర్ ఐ వాంట్ ఎఫ్ ఓన్ని, ఎఫ్ వై, I want fy is equal to f into sin theta, f into sin theta. F into sin theta. So similarly I got that sin theta, right, sin theta. So this is the system to get the resolution. Therefore the same thing, F is equal to f sin theta, alage fs is equal to f cos theta. So how I take the sign convention, because our coordinate axis having the our coordinate axis has the y axis and x axis. So this is the axis we have, and this one is a positive x axis, this one is negative y axis. So x axis and y axis, this one is positive, here it is positive, and here also it is positive. These are the positive y axis and positive x axis. So remaining what happens, these are negative x axis and negative y axis. So those are the negative. So the component along x-axis is taken as positive if it acts towards the right. The component along the x-axis is taken negative if it acts towards left. So according to the this thing, and these both are deal with the left and right. axes. And similar way for the y-axis, if it acts upward, then it is a positive. If it acts upward, it is a positive. If it acts downward, then it acts negative. Right? So that is the conventions for the force after resolution. You should take these sense, because we already understood that a force has the sense and direction. Hence, accordingly, you have to put the positive sign and negative sign. So this is the checking. If I want to know whether I got the f of x and f of y are really equal to the their sum will give the resultant or not. So this is the formula you can use to find out the cross check of the resultant or inclined force. So r is equal to square root of f of x square plus f of y, where f of x and f of y as per your f cos theta or f sin theta according to the theta position. Direction of the resultant for two component forces, theta is equal to tan inverse f of y by f of x. This is purely for your checking. Now you try this one. From this, there are n number of forces are there by using the analytical method. So just we are added here only a sigma symbol. You should notice here it is not the sigma f of x. As earlier it is only f of x. There is no sigma here, right? Here also no sigma, right? Here also no sigma. Here also no sigma. But see here, now we are taking the sigma in the analytical method or resolution of forces. Here it is the sigma, here it is a sigma, and even in the direction also we are taking as a sigma. So because number of forces we are taking 1, 2, 3, 4 or 5, 6, 10 number of forces also you can deal, and all the forces have been get the resolution of forces in the components of f of x and f of y, and that means summation of the forces in x direction and summation of forces in the y direction, and you get the resultant of the same by using the formula r is equal square root of sigma f of x square plus sigma f of y square, and theta is equal to tan inverse sigma f of y by sigma f of x. That gives the direction of the resultant of the total forces. So what is the sigma f of x? I am getting the summation in the components of all the forces resoluted towards the x direction. That might be positive or negative. So f of x might be a negative or positive. These are positive or negative as per right or left direction, right? Similarly, y are positive or negative. Here also y also positive or negative as per upward and upward, downward direction. So please mind this one. So while you are getting the summation of the x and y, you should note that their direction has to be taken in consideration. Okay? And therefore, finally, after summation, I am getting the forces. So by using the same, I just taken a two quantities which here the problem can be solved in parallelogram of forces. But now I am trying to using the analytical method. So in this analytical method, what you have to do? Summation of the forces in x-axis and summation of the forces in y-axis. So you see here, I taken this 1500 newtons, and here is units are different. You please see that here units are different. Here it is a newton, and this 55 is a kilonewtons. So you have to see that whether both are should be converted into one unit only, right? So you should see that. So for this, I need to get the sigma f of x and sigma f of y. Hence, I am taking each force and getting the components of in x-axis and y-axis directions. So along the x-axis, 15,000 Newton is purely in x-axis. Hence, theta is 0 for this one towards the direction of the positive axis. Hence, the same value is taken as. For the y-axis, theta is 0, and but the component is sine 0, hence 0, because sine 0 is 0, hence it gives the 0 Newton. For the component of 55 kilonewtons, which is makes an angle of 60 degree with respect to the horizontal axis or with respect to the 15,000 Newton force. So I am taking their components. Therefore, x-axis is equal to 55 cos theta, because it adjacent side will be the 15,000 only. Hence, it gives the cos theta 27.5 kilonewtons. Being it acts towards the right side. So how I get this one is right side? I said that it is the right side of the positive axis. You see here, this is the situation. So 55 kilonewtons, I am making it into the x-axis side, just turning this one, you got pure right side, right? Hence it is positive, right? In the similar manner, component along y-axis, so I should turn the same thing into the y-axis side. So now I am making this into the y-axis side, so a little bit towards the y-axis side. So I got the pure straight y-axis. So it is upward direction. You got this one in upward direction. Hence upward is positive. Right? This is the way you have to see that rotation, whether it gives the positive y direction or negative y direction, or positive x direction or negative x direction of that force. You have to make it into the turning towards the rotation of towards the axis. Then you get that sense which is a positive or negative. Right? That is the most important in the resolution of forces or analytical method. Right? So after getting the values, I am substituted in the same thing has been substituted in the formula sigma f of x and sigma f of y. You got those values as sigma f of x is equal to 42.5 kilonewton, sigma f of y 47.63. Then resultant will be the square root of 42.5 square plus 47.63 square. You got the resultant 63.83 kilonewton, which has been represented here as a resultant. And theta is also get the direction with respect to the positive x-axis, that is 48 degree 15 minutes, by using the formula tan theta is equal to tan inverse f, so, f of pi by f of x. Here it is, note that this is also a sigma, it is sigma f of pi by sigma f of x. Now you simple solve this problem using the same manner at your home. It in your leisure time, you just understood the differences between these all four systems, like that uh, parallelogram law of force, triangular law of force, Lami's theorem, then polygon law of force, then this last one, fifth one, is resolution of forces, right? You just differentiate all this by making some few problems and understand better them, right? So concluding this session, We understood in this session Lami's theorem, how it is helpful, and the computation of resultant of a system by using the law of polygon of forces and resolution of forces or analytical method.